Ocean acidification happens when excess carbon dioxide from the atmosphere dissolves into the ocean, forming carbonic acid. This lowers the seawater's pH, making it more acidic, which can harm marine life and disrupt ocean ecosystems. Global warming increases CO₂ in the air and means more CO₂ gets absorbed by the ocean, causing acidification. We must take climate change seriously. Our planet, oceans, and future generations depend on it.
We prepared 6 containers filled with seawater. Container A was the control, while containers B and C received 10 ml and 50 ml of vinegar to simulate different levels of carbon dioxide. The materials we used were 3 table lamps, 2 recycle boxes, vinegar, pH meter, and seawater. This is our experiment setup with all containers and materials arranged and ready. In the first setup, 3 containers were placed in a box under one lamp to simulate a lower temperature environment. In the second setup, another 3 containers were placed in a different box under 2 lamps to simulate a higher temperature condition. First, we will fill 6 containers with seawater. Vinegar was added into the containers according to their assigned concentration levels. After that, we will measure the pH of each container that contained vinegar. All containers were left under their respective light setups for 1 hour. This is how the containers look under the lighting setup. After 1 hour, we measure the pH again to observe any changes caused by CO₂ concentration and temperature.
For setup 1 result, for container A1, we have the value for pH before and pH after 1 hour plus lamp. And for container B1 and C1, we have the value for pH before plus vinegar, pH after plus vinegar, and pH after 1 hour plus lamp. For setup 2 result, container A2, we have the value for pH before and pH after 1 hour plus lamp. And for container B2 and C2, we have the value for pH before plus vinegar, pH after plus vinegar, and pH after 1 hour plus lamp.
Our experiment was a simplified model and had limitations. The amount of heat from table lamps may not have been sufficient to mimic real ocean warming, and we did not directly use measure CO₂ gas, and we only assume based on the vinegar concentration. In conclusion, vinegar concentration clearly impact acidity, while temperature change due to lighting had minimal effects on CO₂ behavior in this setup. This helps us understand that ocean acidification is primarily driven by CO₂ levels, but temperature can play a secondary role in complex natural systems.